Hello everyone. Today in this lecture, we will discuss about your solution of integral equation, how we can use your convolution theorem to solve certain type of integral equation. So let's check one example is solving this integral equation, just recall that what is your convolution theorem, because we have to use this convolution theorem to solve this. So just check what is the just recall convolution theorem. What is convolution theorem? Suppose we have Laplace of f of t is your f of s, and Laplace of g of t is your g of s. Then Laplace of convolution of f and g is equal to fs into gs. So this is the convolution theorem. And how we can define your convolution of f and g? F star g means what? Convolution of f and g. And how it is defined? It is integration from 0 to t. That means your f star g is equal to integration from 0 to t f tau g t minus tau d tau. Is not it? So this is how we define your convolution of two function, and this is your convolution theorem. Already we have discussed in the previous lecture. So now how to solve this integral equation? So this is an integral equation. This is an integral equation. What is this? Y of t is equal to t plus integration of y tau sine t minus tau d tau, and its limit from 0 to t. So to integrate means, so to solve this integral equation, how to use your convolution theorem. So just check this term can be written as, this is remain unchanged, because y of t equal to t plus, just see this. So from the definition of convolution, just check, this is your f tau gt minus tau d tau and limit 0 to t. So you can check here, this is as a definition of convolution. So what we can write this integration? For this integration, what we can write using convolution notation? What we can write? This is nothing but yt star sin t. Yt star sin t, is not it? Because if you define, if you find, if you want to find the convolution of these two functions y and sin t, then what will be this? Integration from 0 to t, then y of means f of tau you have to write, so that's why it is y of tau. Then sin t, in place of t what we have to write? T minus tau, so that's why t minus tau. Okay, so this is nothing but your convolution of y and sin t. So this integration can be written as convolution of y and sin t, right? So that's why you can write like this. Now just come to the next line. So what we have to do now? Just take Laplace on both sides, as in your solution of differential equation. Same process, just take Laplace on both sides. If you take, then what you will get? Laplace of yt and Laplace of t plus Laplace of y star sin t. Now in the right hand side, Laplace of t we have 1 by a square, we know that. Now from convolution theorem, now this is what we have to find: Laplace of y star sin t, Laplace of y star sin t, Laplace of convolution of y and sin t. So to find this, you can use convolution means theorem. This is f star g, this is y star sin t. So what is this? F of s into g of s. F of s into g of s means Laplace of y into Laplace of sin t. So Laplace of y star sin t means Laplace of y into Laplace of sin t. Clear? So Laplace of y, then Laplace of sin t. Okay. Next, 1 by a square plus Laplace of yt into, and we know that what is Laplace of sin t? It is 1 by a square plus 1. It is 1 by a square plus 1. Clear? So now just what is our objective? To find out the y, to find out y of t. So take this is Laplace of yt here, one Laplace of yt, again in our left hand side is also Laplace of yt. So take these two terms to the left hand side, and so what we will get? Laplace of yt, and what will the term? Come on, this is from this term it is 1, then if you take to the left hand side it will be negative, so 1 minus 1 by s square plus 1. So from it is 1, and from this term it is minus 1 by s square plus 1, and in the right hand side it is 1 by s square. So just solve Laplace of yt, and if you solve this term it will be s square plus 1 minus 1, so s square plus 1 minus 1 divided by s square plus 1, that is equal to 1 by s square. Clear? So Laplace of yt is equal to, what we will get? 1 minus 1 cancel, so s square by s square plus 1, s square by s square plus 1, and in the right hand side it is 1 by s square. So if you take s square by s square plus 1 to the right hand side, what will get? 1 by s square into this term will be multiplied, this term will be divided. So 1 by s square into s square plus 1 divided by s square. So s square into s square, so it will be s fourth. So s square plus 1 divided by s fourth. Clear? So if you separate it, it will be 1 by s square plus 1 by s fourth. 1 by s square plus 1 by s fourth. Now, because we have to find y of t only, so how to find this? Take Laplace inverse as usual process. Take Laplace inverse on both sides, so that we can find y of t. So take Laplace inverse. So Laplace inverse of y of t means Laplace cancel. So this is only y of t, and the right hand side it will be a Laplace inverse of 1 by s square and Laplace inverse of 1 by s fourth. Separately you can operate it, because we know that it satisfies your what? Linearity property. So that's why y of t equal to Laplace inverse of 1 by s square, that is t only, and Laplace inverse of 1 by s fourth means what? We know that t cube by 3 factorial, that is t plus t cube by 6. So y of t is equal to t plus t cube by 6. This is the answer. Okay, so in this very simple procedure, just what is the process? Just write this type of term using your convolution, then take Laplace on both sides, then find out the y of t, means Laplace of y of t, then after that take Laplace inverse on both sides, so that you can find y of t. Okay, so in this type of integral equation we can solve using convolution theorem, right? Now suppose we have to find Laplace inverse of fs by gs. Okay, so where your gs will be in the form gs is equal to s minus a, means it's a product of linear factors, s minus a into s minus b into s minus c, or it may be s minus a whole square, s minus b into s minus c. In the third case, it may be s minus a into, means your product of a linear factor, and another is a quadratic. Or it may be product of two quadratic factors, where it is a square of quadratic factors. Okay, so if your gs will be in this form, then how we can find Laplace inverse of this? So generally we can solve Laplace inverse of fs by gs, writing this fs by gs as a sum of partial fractions. So how we can write this partial fraction, this fs by gs, as a partial fractions if gs will be in this form? Okay, so now check. So if it is only it's a product of linear factor only, then just write fs by gs is equal to some constant y s minus a, some constant into s minus b, plus some constant into s minus c. Clear? Now we can take the LCM, then compare the coefficient of power of s, right? We will solve this problem. Just write this format. Then if in the second case, if it is a product of linear factors, and one linear factor is having the power is 2, means square, s minus a square. So that's why what we have to write, a1 by s minus a, some constant in x minus a, because it is s minus a whole square. So a1 by s minus a, then plus a2 by s minus a whole square, for this only. Then one term s minus b and another factor is s minus c. So a3 by s minus b plus a4 by s minus c. Clear? Similarly, in the third case, it's a linear factor, it's quadratic. So for linear factor, just some constant into s minus a, and for quadratic, we have to write a2s plus a3 like this. a2s plus a3 divided by this quadratic factor. Right? And in the fourth case, since these are two quadratic factor but one is square, the degree of one quadratic factor is square. That's why for first quadratic factor, just write a1s plus a2 according to this. a1s plus a2 divided by one quadratic factor, first quadratic factor, then plus this is, since it is square, so that's why first we have to write a3s plus a4 divided by the bracketed term. Then since it is square, so another time we have to write a5s plus a6. Okay, these are some constant. a5, a6, a3, a4, these are constants. So a5s plus a6 divided by its square. Okay, so what we note that if it is square or it is cube, suppose it is s minus a cube. Here it is s minus a cube. Then what we have to write? What we have to write? a1 by s minus a plus a2 by s minus a square plus a3 by s minus a cube. Right? So according to this, if it is, means according to the degree, we have to take this that much of terms. Clear? So just note it. So using this partial fraction, we can solve problems. Okay, we can solve these problems just now. Now to try to find Laplace inverse of s plus 1 divided by s into s minus 2 into s minus 3. Okay, so using partial fraction, how we can solve? So to solve it, first write this term s plus 1 by s into s minus 2 into s plus 3 as a sum of partial fraction. So because they are the linear factors only, s is a linear factor, s minus 2 is a linear factor, s plus 3 is also linear factor, means degree of s is only 1. So that's why, so what we have to write according to our procedure, a1 by s, some constant by s first factor, some constant into second factor, some constant into third factor. Okay, so after writing this, just try to solve it the right hand side. So taking LCM, it is s into s minus 2 into s plus 3, and the numerator will be a1 into s minus 2 into s plus 3 plus a2 into dividing s minus 2, so remaining term is s into s plus 3, then a3 into s minus 2 into s. Yeah. So now if you solve with the left hand side and right hand side, the denominators are same. Denominators are same, so just cancel it. So what is the remaining part? S plus 1 is equal to, the numerator will be same. So s plus 1 is equal to, just multiply it. a1 into, multiply these two factors, that is s square plus s minus 6. It is s square, then minus 2s plus 3s. So it is plus s, then minus 2 into 3, so minus 6. Then plus a2 into s square plus 3s. Then a3 into s square minus 2s. Okay. Now, because we have to find the constants only. Because we have to find the constants, so try to compare the coefficients of a different power of s. Okay. So first compare the coefficient of s square in the left hand side as well as right hand side. So in the left hand side, there is no term of s square. Okay, so the coefficient of s square is 0. Now in the right hand side, the coefficient of s square is, here it is a1, here it is a2, here it is a3. So a1 plus a2 plus a3, 1 plus a2 plus a3, but left hand side there is no a square term, so it is 0, right? Similarly, compare the coefficient of s. So from this, on the right hand side it is a1, then it is 3, so 3a2, then minus 2a3, minus 2 here, minus 2a3, so a1 plus 3a2 minus 2a3, a1 plus 3a2 minus 2a3, and in the left hand side the coefficient of s is 1, clear? So it is equal to 1. Now compare the constants. In the left hand side only one constant, it is 1. In the right hand side, that is a1 into minus 6, so minus 6 into a1, minus 6 a1, and in the second and third term there is no constant term. So 1 is equal to minus 6 a1. So what will be a1 here? a1 equal to minus 1 by 6. Clear? Now to find a2 and a3, just put the value of a1 here in these two equations. Put the value of a1. a1 is minus 1 by 6. Already we got it. And put in these two equations the value of a1. So what will get? a2 plus a3 is equal to, see, a1 just write in the right hand side. So minus 1 by 6. So it will be plus 1 by 6. So a2 plus a3 equal to 1 by 6. And 3a2 minus 2a3 equal to minus 7 by 6. Okay. So, so 2a3 plus 2a3, that is 2a2 plus 2a3. Okay, so to solve these two equations, so multiply 2 in the first equation. So 2a2 plus 2a3 is equal to 2 by 6, and we have 3a2 minus 2a3 equal to 7 by 6. So just add these two to cancel, so that this term will be cancelled. So 5a2 is equal to 7 by 6 plus 2 by 6, this is 9 by 6. So a2 equal to, just solve, we have to solve these three equations only, nothing much. So a2 equal to 9 by 30 or 3 by 10. The value of a2 equal to 3 by 10, and the value of, just put the value of a1 and a2 here, or directly put here the value of a2, so that we can find a3. Just put it here. So a3 equal to 1 by 6 minus a3, sorry, minus a2. So a2 is 3 by 10. So 1 by 6 minus 3 by 10. So minus 5 minus 9 by 30. So a3 equal to this minus 2 by 15. So now we got all the constants what we have assumed in the sum of partial fractions. So now put only here the values of a1, a2, a3 here. So to find Laplace inverse of s plus 1, this, so this value, this bracketed term is equal to what? This plus this plus this. Okay, so Laplace inverse of this term means Laplace inverse of this plus Laplace inverse of this plus Laplace inverse of this, because it satisfies linear property. So Laplace inverse of s plus 1 by this means Laplace inverse of a1 by s, Laplace inverse of a2 by this, Laplace inverse of a3 by s plus 3. Now a1 is constant, a1 is what? Minus 1 by 6, so minus 1 by 6, and Laplace inverse of 1 by s is 1 only, we know that. Then plus 3 by 10, because the value of a2 is 3 by 10, so 3 by 10 into Laplace inverse of 1 by s minus 2, Laplace inverse of 1 by s minus 2, so it is what? It is over 2t, minus a3 means 2 by 15, so minus 2 by 15 into Laplace inverse of 1 by s plus 3. So what is Laplace inverse of 1 by s plus 3? It is e to the power minus 30. So the Laplace inverse of the bracketed term what we have to do is minus 1 by 6 plus 3 by 10 into e to the power 2t minus 2 by 15 into e to the power minus 3t. Okay, so likewise you can write the term as a sum of partial fraction, then you can easily find out the inverse. Okay, so you can on the different other problems, checking the denominator, the form of denominator, you can use the 4 types what we have written, the 4 types to write the given term as a sum of partial fractions. Okay, so it will be easy to solve it, right? So thank you. Again, we will meet in the next lecture with a new topic. Okay, thank you.